Hello, everyone. Hi, and welcome. Good morning, good evening, wherever you are joining us from. We are very excited to start today the new series at the Reactor Generative AI for Software Developers. And I'm going to talk to you shortly about this series. But before, I wanted to introduce you the code of conduct for our events here. So Microsoft Reactor is still part of the following the code of conduct of Microsoft. So please take a minute to read this. We also have probably move my face a bit so you can also scan the QR code, and then you can see it online if you wish. Please be respectful in the chat. So a bit of introduction. My name is Moria Dror. I'm a regional Reactor PM at Microsoft. Together with me here is Jordan Dorr, the events and program manager at the Reactor, and Adi Stein, regional Reactor at Microsoft. So the three of us really worked hard on this, on the content for this series together with the speakers, and we really hope you enjoy it. A bit about the Reactor. The Reactor is a technical hub for developers, startups, and all kind of tech professionals. We offer free programming and learning opportunities for whoever wish to learn about any tech area. We are recently focusing more on AI, and we have great events that you can find on our website. I'm going to share with you it shortly. The Reactor is empowered by Microsoft Learn. Microsoft Learn is a free platform for learning that Microsoft offers. You can find really unlimited, a lot of learning opportunities, learning paths, modules, certifications, and so on that you can take at your time from anywhere, wherever you are, on your own pace. It's a really great opportunity to learn for free and about anything that you find interesting that's relevant for you. For example, you can scan the QR code on the screen, and we are going to share it soon with you in the chat as well. But here you can browse all the learning options that we have. We have a learning path starting from 30 minutes to 16 hours that you can choose. You can take certifications and become Microsoft certified. You can watch learn events, and you can browse all the different live and recorded events that we have there. And this is how it looks like. You choose your module, and it is spread by different categories. It tells you exactly how many minutes it will take to complete each one. So highly recommend it. We're going to share the link to Microsoft Learn. You can also scan the QR code now on the screen. This leads you to learn models that focused exclusively on AI. So it's an AI learning hub where you have all the modules and learning paths that you can find on AI offered by Microsoft. Here you can find in this QR code, you can actually look at today's event and all the upcoming events that the Reactor offers worldwide. So not just in this time zone, any time zone, anywhere in the world. You can subscribe to our events and to our newsletter and stay updated with the upcoming events. So back to today's series. Today's series, as I mentioned, is GenAI for software developers. What's unique about this series is basically from senior software developers in the R&D center of Microsoft talking to you about products and areas that they are working on. So it's really from them directly to you. Today's session is going to be on focusing on how to create your own Copilot using Semantic Kernel. Second session next week, it's going to be about Copilot. The next one is documents as a service, and then the last one will be on LangChain. This is the first part of this series. We are going to continue this series again in the next month, but so far we have those 4 confirmed events. So hope you enjoy today's session and make sure you sign up for the next session next week at the same time, same day. And next week, we are also going to kick off another series at the Reactor called Spotlight on Application Innovation and AI. So if this is something relevant for you, if you wish to learn more on that, do scan the QR code and check our website to find out more about this series. We are starting it on the 27th of February. Yeah, so that's going to be another series that we are starting. So without further ado, I'm gonna hand it over to Moaid Motut, the senior software engineer, at Microsoft. Is going to talk to you, introduce today's session. I really hope you enjoy it. If you have any comments, by the way, feel free to post them in the chat. This session is recorded and is going to be available on the YouTube channel of the Reactor. We are also going to share the link in the chat. So feel free to ask your questions. Moaid will take time at the end to answer any questions that you may have. And that's it for me. Enjoy it. Over to you, Moaid.
Thank you, Maria. So thank you everybody for joining the session. I'm Ayad, and I'm going to talk about Semantic Kernel and how we can use it to build our own copilots. So AI or LLMs has revolutionized the way people interact with computers. I think that today it's very hard to find someone that is not using an LLM in any sort of capacity. And I think that LLM is, a technology that we may face once or twice in a lifetime, where it really disrupt the technology, the current technology. So I think that the last time I thought something like that was the first time the iPhone 1 or the first smartphone was introduced. I think that LLM is really revolutionary in that way. And it's actually like it provide AI abilities for the masses. Everyone is using LLMs and AI. Even my parents, small students in schools. And I think that for us as programmers, it has affected us in multiple ways. For example, we can be more productive by using AI in order to find bugs or to help us generate code. But secondly, it affects us because we have to adapt. So AI is going to be used more and more, and we have to adapt our code. We have to integrate AI into our applications. And we have to do that in order to stay relevant and to compete with other products. So what are the objectives of this session? There's a few. First of all, I'm going to talk about semantic kernel, the basics of semantic kernel, what it is, why do we need it, what does it provide. Secondly, I'm going to show how we can use semantic kernel in order to integrate AI abilities into our application. It's really easy. And we also will look on how we can compose prompt programmatically. I'm not talking about prompt that we as humans send ChatGPT, for example, but on prompt that we can build programmatically with a template engine where we can provide variables and parameters and manipulate them. And lastly, I'm also going to show how easy it is these days to just download an LLM or basically a small LLM so that it can fit your memory, but download an LLM offline into your own machine or into your cluster, whatever, and then run it and integrate with it directly with semantic kernel. So it's that easy. And before we start, a few word about myself. So my name is Muayyad Hathout. I'm a software engineer at Microsoft, currently working on some Azure stuff. Previously to joining Microsoft, I was an Azure MVP. I am the co-founder of Code Digest, which is a local user group here in Israel. I'm also the co-founder of .NET Bond. .NET Bond is a community inside Microsoft ILDC by .NET developers for .NET developers, and I'm also the author of the Dumpify package, so you can check it out. So how can we become AI developers? Where today we don't need any PhD. Where historically, when we say that when we needed to add AI into our applications, we had to have some sort of deep AI knowledge to train data specifically for our needs. We had some sort of degree about AI. It was a bit more complex and more time consuming, but today it's very easy since LLMs are really easy to use and they are publicly available. They are considerably cheap, so everybody can use them. And in order to use AI these days, or to be an AI developer, we don't need to invent the wheel each time. We can just use an LLM, and we can integrate with an LLMs programmatically using tools such as LangChain or Semantic Kernel, as we will see in this session. So before we can start, we do need some sort of knowledge. It's really the bare minimum of knowledge that we need in order to squeeze every drop of potential from LLM. So let us just do a really quick introduction about what an LLM is and what are the important bits for this session. So an LLM is a neural network that is trained on a really huge data set. If you are talking about OpenAI, then they are literally trained on a snapshot of the entire internet. And one property of LLMs is parameters. So parameters is, you can think about it as it's how LLMs can store or think about data. So whenever there's more parameters on an LLM, it can do more complex processing. Although if we have two LLMs, one of them is with much more parameters than the other, it doesn't automatically or necessarily say that the LLM with a higher number of parameters is better than the one with a lower number of parameters. But there is a correlation between the number of parameters and how complex processing can an LLM use. LLM, of course, is stands for large language models. And another property of LLMs is that they are stateless or have some sort of a short-term memory. We can add context, and we will see how we can do that. But basically, they are stateless, and they can provide information about the data set that they were trained on. And if we ever need to provide more data, then we need to provide it in some way. And as I said, we will show how we can do that. And lastly, LLMs are probabilistic engines. So what LLMs does is they try to figure out what is the next word that we expect it to appear in the result. And there's a lot of statistics and probability. We won't talk about that, but we will see how we can define or change some of these parameters when we are working with semantic kernel. And if you can see here on the right, we can see that in 2019, the GPT-2 model had 1.5 billion parameters, which sounds a lot. But if you compare it to 2020, only 1 year afterwards, with GPT-3, it had 175 billions. And if you are comparing to with 2023 with GPT-4, it had 1.4 trillion parameters. So the number of parameters and how complex of computation LLMs can do is really improving exponentially. So LLMs are getting better, and we are just starting to squeeze the potentials of LLMs. So the future is really bright. So how can we interact with LLM? Well, we use natural text, usually in English, although we can use other languages as well, but English is a main language since a huge chunk of the internet is written in English. And as I said, LLMs were trained on snapshot, or those OpenAI specifically, on a snapshot of the entire internet. And so we provide an input for LLMs using natural text, and LLMs outputs also natural text containing the results. And for that to work, there's a process called tokenization. So the LLMs tokenize the input that we provide, and it also tokenizes the outputs. And how tokenization work, or what is tokenization? Well, a token can be a single character, a fraction of a word, or an entire word. And there's a correlation between how common a word is in the English vocabulary to the number of tokens. So if a word is common, it should be represented with lower number of tokens. And we can see an example of that. So there's a really cool website for OpenAI called Tokenizer. And what we can do here is we can write some words or sentences, and it can show us like how many tokens it used. So if I just enter a character, for example, A, we can see that it only uses one token. Even ABC uses one token. So let me try to add some sort of letters that it did not, should it anticipate after ABC, something that is not D. For example, ABC K. We can see now that it has two tokens. And although lengthier words should have more tokens, it not necessarily say that a long word will have more tokens. So for example, if you write difficult, okay, so difficult is 2 tokens, although it has 9 characters. And if I write John, so it's only 1 token since John is widely used, but if I write my name, then it's also 2 tokens. So there's algorithms or different algorithms in order for creating tokens. This algorithm is specifically for GPT 3.5 and GPT-4 models, and other LLMs may have other algorithms that they use. But token is really important since LLMs has a limitation around how many tokens we can send in each prompt and how many tokens they can generate. So it's really important to track. And we are also billed, or one of the variables for our billing is also around tokens. So it's really important to keep track on how many tokens you are using. Usually, if you're using less tokens, then it's cheaper and the processing maybe even be faster in some situations. So according to OpenAI, statistically speaking, each 100 tokens is about 75 words. There's libraries like tick token or some, or we can also use it built in with Semantic Kernel in order to get a sentence and tokenize it. So it's really easy to use LLMs. We don't need to host each one on our machine. We can use an LLM as a service. So for example, there's an OpenAI model that we can use. We can pay OpenAI and use their models, or Google's with Gemini. Microsoft has the Azure OpenAI resource that we can use, and I will show you how we can create one and use it in this session. And of course, there's also others. So let us see how can we use Azure OpenAI service. What's great about it is that in contrast to OpenAI and maybe other LLMs as a service, Azure OpenAI service won't save your data. It won't retrain LLMs on your data. Your data stays confidential. And that in contrast to other providers. So for example, it's really not safe to send confidential data to OpenAI's direct APIs, since according to their license, they can retrain their LLMs on the data that was provided by user prompts. That won't happen with Azure OpenAI service, so it's really great. So let me show you the Azure portal when I already created one. So here we have a resource group. I call it OpenAI demo. And in that resource group, I have an Azure OpenAI resource. So if you click on it and see what we have here, so this is the resource. It's an ARM ID. It's a resource that we can deploy and interact with. And what's important here is the keys and endpoints. So keys and endpoints determine what is the endpoint from the internet that we can go and access that resource, and also the private or secret keys that we need in order to authenticate and authorize. But generally, in order to really use the Azure OpenAI resource, we won't do that in the Azure portal. There's another portal called, okay, let me connect to it really fast. So there's a portal called Azure OpenAI Studio, which we will use in order to see this demo. So the most important menu here is called deployments. Deployments are the actual models that we have deployed and we can interact with. Here I have 3. I can create more. Currently, Azure OpenAI resource needs some sort of onboarding. There's a link that is in my slides that you can use it afterward. It's also the documentation of Azure OpenAI in Microsoft Learn. But here I have the models that are enabled in my subscription. And in your subscription, you may have other models that are enabled. So what you see here can differ from what you will see in your subscriptions. There's really high certainty, you should see more models than what I see here, since I'm using a limited set of models. And here we can choose from GPT 3.5 turbo models and GPT-4. So most of the example I will do in GPT-4. So after we create a new deployment, we can see the differences. For example, the rate limit on how many tokens per minute we can send. We can see that there's a really huge difference between GPT 3.5 model and the GPT-4 based model, and also in pricing. But before we go to pricing, we can test each of our models in the chat menu here. So we can write anything. For example, I can ask here, the sky is, and here on the right, I can choose which model to use. So for example, this time I'm using GPT-4. I can also play with the parameters. So here I have a few parameters. We will talk about a few of them later. And if I run it, we can see that it has generated a result. It's not important what's currently generated, but we can play with a model in a chat menu just to test things up and to play with the parameters that we have. So what about pricing? We can see here that newer models, for example, what we see here on the top, are more expensive, usually more expensive than other models. And the GPT 3.5 turbo model is relatively cheap. It's really fast. It's way faster than all of the GPT-4 models. Although it's less accurate, it hallucinates more, and it can generate lesser results, generally speaking. GPT-4 Turbo is the new one. It's even a bit cheaper than the older GPT-4. And it's fast, but it's not fast as GPT 3.5 Turbo. So this is really important to notice, because you will feel the delays, and the consumer for your application will also feel them. Okay, so given we have the Azure OpenAI resource, how can we interact with it? We have multiple ways. One way is using REST APIs. As most of resources in Azure, we do have some sort of REST APIs, and all other SDKs are built on top of that REST APIs. We can use the Azure AI Open SDK, or we can use some sort of an abstraction or an orchestrator like LangChain or Semantic Kernel. So let's talk a bit about Semantic Kernel. Semantic Kernel is an SDK which provides us an abstraction. it has a unified set of APIs that we can use to interact with different LLMs. And it has features such as writing plugins, our own plugins, and also extending the LLMs and using and working with memory, and embeddings, which we will talk about. Currently, it's supporting C#, Python, and Java. Generally speaking, there's a parity between the features of C# and Python. There's a few features that exist in C# but in Python, or vice versa. But Java support is very new, and it's working on progress. You can really use it, but it has, as today, less features than the rest of the languages, but they are actively working on it to improve it. So let's see a demo. Let's see how we can use Semantic Kernel. So first of all, it's really easy. We can start just by installing a new NuGet, which is called Semantic Kernel. It's this NuGet here. Okay, this one here. And after we do that, the APIs are really simple. But before we go there, first of all, we need to configure the endpoints and the API keys. Currently, I'm using environment variables in order to load them. Although I have to say that this is okay for the demo, but environment variables are not the securest method that you can use, since they are not encrypted. They are stored in plain text, and any process on your machine potentially can access environment variables. But again, for this demo, they are okay. So I have created here some sort of class called skconfig. This class is defined in this project. It's not part of the semantic kernel, but I'm using it to configure later semantic kernel. And we have here a few properties. For example, the name of the deployment, which is the name that I have provided here. Okay, so for example, this is a name of the deployment of my model, and this one as well. It's a name that I have selected, so it's important to keep track on it. And then we have here the key and the endpoint that we got from the Azure portal. After that, I have created some sort of an interface that I can use to run different examples. It's not really important what we have in that interface, but I will show you just so that I explain this thing that I have added. So we can go to base demo, and we can see here that I have a few things, but generally speaking, I have two methods, one called initialize async and the second one called run async. In run async, I just create a while true loop, and each time I use console readline, what you see here, I get the prompt and I send it to one of the implementers or the extenders of the base demo. So this is what I do generally. There's nothing here that's complex or like important for semantic kernel. It's only for that we can iterate over demos really easily. So the basic implementation that we have for semantic kernel is really simple. We can use the create builder static method in the kernel type, and then we can use the Fluent APIs, really similar to what we have with ASP.NET Core. So we can just say create builder and add Azure OpenAI chat completion. So there's chat completion and there's text completion. The difference is with chat completion, we can also provide later history and context so that LLMs can remember things that we already talked about. And I'm providing here the deployment name, the Azure endpoint, and the Azure OpenAI key. So as the name of the method shows, I'm using Azure OpenAI chat completion. Let's say I wanted to use OpenAI directly, not the Azure one, but the OpenAI directly. So I can just exchange the first line with the second line. It's that easy. Okay, so for the OpenAI APIs, we only need the model ID and the AI key. We don't need the endpoint because it's the same endpoint for everything. But it's really, really easy to move between these two. Secondly, whenever I have user input, I just use a method called invoke prompt async in order to invoke this prompt in the LLM using the configurations that I have, which currently I'm using everything by default. So let's try and run it. So I can just write .NET run project. And I now need to provide the name of the demo. So it's called basic 00. Okay. Let's give it a second once it compiles. So here in orange, we can see that it's found this class basic00.cs, and it's asking us, how can I help you? It's also a string that I have defined for this demo. And we can ask it, for example, tell us about Microsoft in 10 words or less. And it has provided an answer. So we just connected to Azure OpenAI resource. We sent it a prompt and received a response back. Cool, but it's only the beginning. So let's try and add functionality. For example, let's say that I want to implement some sort of an ordering system, maybe for a restaurant or for our company store or whatever. So here I have a prompt called, or it says what product is ordered in this request. I'm receiving a user prompt, something that user has written, and I'm adding it programmatically manually to a string. So what product is ordered? What product is ordered in this request? I am concatenating the user prompt to that line, and the line after it, I'm providing the LLM. I'm saying it. A product can be coffee, burger, water, shawarma, schnitzel, or beer. So I'm telling the LLMs what are the possibilities. So let's try and okay. And before I send the prompt to the invoke prompt async, first of all, I'm building the new prompt, which again, it's just concatenating the user prompt to the prompt that I have showed you. And if I'm going to run it again, this time it's called basic 01 order 00. So let's say that I want to order a burger. We know that burger is in the allowed list. We can see here it's in the allowed list here, okay? And the result that we got from the LLM is, based on your request, the product ordered is a burger. So it's really cool. But let's try to order something that is not in the list. Let's say I want to order a pizza. So this time it knows that pizza is not one of the requested, but sometimes it will just work as normal. It will tell you, okay, you have ordered a pizza. And secondly, notice how the format of the result is not consistent. So let's try and make it more consistent so that we can interact with it either in our applications. This time, I'll just run the next demo, which has a newer prompt. So I'm just adding at the end, if the product is not in the list, return not available. Let's try and run that instead. So I just change here the name of the demo. And let's try with burger, which is something that we know that it's in the list. So it's working. And let's try it with pizza again. And we got not available. So it's an improvement. And as I said, even though here it says that the product is not in the list, sometimes it will just provide you with a result because our prompt is not specifying what we should do when the product is not in the result. But let's try and make it even better than that. What I'm saying here is that, okay, so first of all, if the product is not in the result in the list, return not available, as we saw in the last demo. But I'm also adding, if a user has requested multiple items, just return bad request. Okay. And lastly, I'm also requesting here that the result will be in a JSON format. See how that I can provide some sort of variables inside the prompt, and the LLMs will understand that it should change or use this variable or placeholder with the actual results and generating a JSON. So this is very convenient, since it's really easy to deserialize a JSON into C#. So I can just write a new type that can receive the values from the JSON, and it will be easier to interact with. So let's try. Let's try to use demo. So let's try to do everything that we did until now. If I specify burger, it will return product burger, which is really cool because it's using here JSON. And if I request a pizza, then it's saying not available. And if, let's say, I want a burger and a beer, then we'll get bad request. So of course we can customize it how many, like, so that it will return results that are easier for us to parse. But it's working great. It's really easy to do all of the things, to customize it how we want. The problem here is that, as you've seen, it's starting to be really hard to maintain these strings, and in case that we have many other variables, sorry, using string concatenation and string interpolation can be a pain. So we do have features in Semantic Kernel that make this easier. The feature is called prompt. It also had an older name. If you're going to use an older version of Semantic Kernel, it has a name which is called Semantic Plugins or Semantic Skills. But today, with a newer version, it's just called prompts. And how prompts work is that we have a folder that we specify the name of that. I called it prompts, which is currently the convention. And in it, we have some sort of prompt plugins or predefined prompts that we can use with the template engine. So here I have a prompt called order, and we can see that it has two files. The first one called sk prompt. Sk is Semantic Kernel. It's also the convention. It expects these two files to exist. And I just written basically the hard-coded prompt that we saw earlier. In this txt file, I made the list of products a bit like more easier for us to maintain. We saw that even in a single line, it was easier for the LLM to understand and parse. The rest is identical. And in the config JSON, it's configuration for the LLM when we send that prompt. So first of all, we have description. The description is very important. We will see later how, but LLMs understand when or what they should do when invoking this plugin. And it's really important to provide a good description for both the prompt and the variables. So here we have a list of variables, and we can specify the variable names and the description of each variable and whether it's required or not for this prompt. That's meaning that we sometimes can have optional values or parameters. And then we have this configuration. So let's talk about what's important from here. So we have the max tokens. This is the max tokens that are generated from our prompt. The max tokens generated plus the tokens from the request itself should not exceed the maximum tokens that LLMs are allowed to either receive via input or via output. So that's really important. And you can limit or try to limit prompt this way. Secondly, there's temperature. So as we said earlier, LLMs use probability or statistics in order to select or predict the next word, and basically it has a list of possible words that it can output next, and each word has a probability or some sort of number, and LLM usually use the word with the highest probability to be expected, and sometimes it can be more it can use like the number of words and the probabilities may change according to the prompt and what was already generated. And the temperature is like saying how much like if we'll keep it 0, it's meaning that the LLM will be consistent. If we'll given it the same prompt, it should return the same results. It always use the word with the highest probability. Temperature is a value between 0 and 1, and higher level of temperature will make LLMs use or be less it can use different words so that for the same prompt running it multiple times I can get multiple results. It's the effect of that is that LLMs looks like being creative. A higher level or a higher value of temperature, we can get results that are with less fidelity, but they will look like are very creative. So it's really good maybe for generating poems, but not for parsing data that we want to keep consistent. We do have here other parameters that I won't explain in this session, but we can play, for example, with the top P parameter in order to eliminate some of the results. And again, you always need to play with these parameters in order to fine-tune your prompt, but I won't dig deeper into it in this session. So given all that, let's see what we can do. If we go to the next plugin called prompt 00 order 00, we can see here that I'm using a new API called create plugin from prompt directory. So I'm providing here a directory, and Semantic Kernel is loading all of the plugins or all of the prompts in that directory. After doing that, I can just specify which plugins I want to use. So here in the handle prompt, I'm building a kernel argument. Kernel argument is a type that is defined in Semantic Kernel, and I can use it with an indexer, so I can provide all of the variables and parameters that my prompt is going to use. So I know already that it has an input parameter called order, and here I'm just giving it the user prompt. Secondly, we will see how Semantic Kernel can call plugins and prompts automatically, but currently I'm showing you how you can do it deterministically, how we can select a plugin or a prompt and ask Semantic Kernel to call it directly. So I'm maintaining behind the scene in my base demo class a dictionary of plugins that we have loaded here, okay? And I'm reading the plugin called order inside the prompt directory, and I'm just providing it to the invoke async API in addition to the arguments. So let's try and run it and ask the same question. So this time the plugin is called, the demo is called prompt 0 order 0. So let's try and say, I want to order a burger and water. Both of them are in the list, but there are multiple products. So we got bad request, and I can say here burger or only burger, and we should get okay, and we got really fast a good result as expected. So this is a really simple example. Let's try and showcase a more complex example. So here at Microsoft, we work a lot with Cousteau. And one thing that usually is hard for new developers is trying to understand the Cousteau tables. By the way, it's like really the same thing for SQL tables. In that, if you want to read your logs or your database and extract really data from it and understand what's happening in the logs of your system, you need to know the properties or the values of each table. For example, in this case, the Cousteau table, you need to know the schemas. And it's really hard for new developers. Secondly, LLMs or the OpenAI based specifically are really good for writing Cousteau queries, but the Cousteau queries they write are general and not specific to your individual needs or to your team. And what I'm trying to do here is trying to build a plugin, some sort of a copilot that can help us write KQL queries that will generate results that are specific for our needs and our products. So everything here in this file looks all identical or almost identical to the last one. What's different is I'm providing here an input variable that is called input, and I'm using the Cousteau prompt or plugin that I have wrote in order to invoke it with the user query. And if you look what we have in the Cousteau prompt, then in the config, I'm saying here that we need to generate a Cousteau and KQL query to retrieve information about my orders. The variable is called input, and the SK prompt is a bit interesting. So first of all, I'm asking the LLM to generate only synthetically correct Cousteau queries that we can run as is in Data Explorer. I'm also asking the LLM to respect the user's request if they have if the user has mentioned any sort of timing or filtering methods. And I'm also, as an example, telling the KQL query that we only have two tables, orders and logs. And then further than that, I'm telling the LLM which property we have in the order table. So this is only an example, but I did the same for one of our product, and it has way more complex table, and it's worked great as well. And I'm also providing some sort of more data about some of our properties or values in the order table. So for example, I'm telling the LLM that if success can be only true or false, and that category can be either fast food or drinks. So it's only information that I'm providing the LLMs so that when the LLM try to generate a new query, it can use them to generate something that is relevant for me and for our scenarios and not something that is general. And I'm also saying here that the log level may be a number and not a string, and I'm just doing a really fast mapping. So I'm telling the LLM that 5 is trace, 4 is information, 3 is debug, and so on. And what we see here is a convention where we can separate the basic information with the actual request. So here I'm saying that the question is input. this is so Semantic Kernel supports a templating engine. This is a template. Here I'm using the input, the value for the input variable that we have provided in C#. This is the syntax of how we can how we can pass variables. And there in the questions, I'm concatenating the user query after questions, and in the answer, I'm keeping it empty so that the LLM understands that I'm expecting it to provide an answer. So let's go back to the demo. We can see, and let's run it again. So I think it should be stop. Okay, and this time what I'm going to request here, create a KQL query for counting how many orders we received per product in the last 3 days, for example. Right? I I didn't invoke. Oh, okay. So it's telling us that the name of the plugin is not correct. Let's write it correctly. So it's called prompt. Okay, prompt 01 equals 0. Sorry about that. I didn't notice. And now let's just copy paste the prompt already written above here, for example. And we can see that it is using the product property, it's using the order table, and it's also is using the filtering or the time-based filtering that I have mentioned. And I can also, for example, ask it to try and filter errors. So create, or let's try to use, so create a KQL query for counting failed orders, for example. And we can see that it's using the isSuccess as well. So it was really, really easy just by giving metadata about our tables to customize the results that the LLM is providing for us. And imagine that the metadata that you have provided is something that is specific for your SQL tables or database or KQL tables or whatever. You can really easily just create some sort of an AI agent or assistant that can help you generate these results. And basically what you can do, you can even not only generate the KQL queries, you can also generate like the results, like you can also invoke the query and get the result as well, but I did not do that because it's only a demo. So let's try and ask, so let's get back to an older prompt. For example, let's go to the first one, to the basic 00 prompt, and let's try to ask about timing. So for example, let's add what is the date of today? Let's see how can it handle it. And here we have that it can't. It doesn't have information about the date and time of today. It's saying that it was trained on September 2021. So how can we change that? Well, first of all, there's a set of built-in plugins in Semantic Kernel that we can use. This is a list of the supported built-in plugins, and we can see here that most of them do not have support in Java yet, but they are supported in Python and in C#. And if we go to not this one, sorry. If we go to this one, we can see here that I'm calling an API called add from type time plugin. So it's important. It's something that I didn't mention yet. Semantic kernel, or the kernel objects that we build from using the create builder, it has a dependency and dependency container inside of it, so we can register services, and then we can resolve services. And basically, when we write add from type behind the scene, so the semantic kernel is using the iService provider and iService collection object in order to register services and then to resolve services. So here I'm registering the time plugin. I did not write it myself, it is built in. And here I'm using the time calculator prompt that I've written, and we can look on the time calculator. It's really simple. So it has only one input called the user input, nothing special here. And if we look on what we have in the actual prompt, I'm invoking here in the prompt another plugin. So this is how we can do it. Each time this prompt is executing, it first calling another prompt or another plugin. So if I'm saying that the result of the function called now in the time plugin will be concatenated after the word now, and then I'm adding the user input to the input variable, and I'm expecting a result. So let's try and run this plugin. So it's called prompt02 datetime. So prompt02 datetime 00, I believe. Yeah. And let's ask it the same question: what is the date of today? And we got a correct result. And I can ask it, what is the date of next Friday? And also got it right, I think. And also can show us how it did that calculation. It knows that today is the 21st of February and Friday is 2 days from now. So it can calculate it as expected. So it's really easy also adding context to our prompts and to call other or nested plugins from one of our other plugins. So the next feature of semantic kernel that I want to show is called native plugins, or so in the new version it's called plugins, but in the older semantic kernel version it was called native functions. And how they work is that we can write C# code that we run as semantic kernel plugin. So here I have a folder called plugins, and here I have a GitHub plugin class that have two methods, one called top repositories and second one called top repository readme. And here I'm just given a handle. I'm going here and fetching how many, all of the repositories with, I'm fetching and ordering basically the repositories according to the store numbers they have. And here we also have the description. So here I have a description called provide the top rated GitHub repositories for a GitHub user handle. And we can also add the description to the input string, sorry, to the input parameter as well. So, then in the actual plugin, I'm just calling add from, sorry, in the actual demo, I'm calling add from type and providing the GitHub plugin that I have written. And what we have here is has changed in the handle prompt. Is at first I'm adding a new configuration called OpenAI prompt execution settings. So OpenAI has this cool feature. This feature is not built into all of the LLMs, but OpenAI has it, which if we can provide a list of tools or a list of functions, we can ask the LLM to generate some sort of a plan or to generate a result that if we can run it using the functions or the tools that we have provided, we will get the final result. So semantic kernel knows that and can support that. So here we are saying that we are providing a list of tools to Semantic Kernel, and we want Semantic Kernel and the LLMs to try and invoke the function or the plugin automatically. We don't need to get a result saying how we should run the query. We need to get a final result automatically. And secondly, I'm using a new API. So because I've added here the OpenAI chat completion, then I can use the chat APIs, and this is one of the chat APIs. So as I said, the kernel is a dependency, has a dependency container inside of it, and I can use, for example, get required service in order to get a required or a registered service, as I'm doing here. And let's try and run this plugin. So this time it's called plugins 00 GitHub 00. And let's call it what are the top rated repositories for my handle. So this line here, I'm printing in my plugin. If you go to the, you go here, actually here, we can see that I'm printing this line, what you can see here. But let's see what the LLM has written. It's called I want doesn't ever retrieve. Okay, I think that it has some sort of an maybe transient error. We can also always include retries if we want to. Let's try do it again. Maybe it did not. Okay, so it's not my. So it's Moed out, not Moed handle. Sorry about that. So once I'm written my real name, now I'm getting the result of my top rated repositories, and I can ask it to filter it down for 3 repositories, 10 repositories, 5 repositories, whatever. It was really simple in adding this functionality to the prompt. So currently, if we are going to ask it about something that you already asked about, it won't remember because we are not sending the history. It needs a history or to provide the history in order to so that we can ask it so that we can implement something that is chat based and not a single prompt based each time. In order to do that, we can use the same iChat completion service, and we have a collection called chat history defined in the semantic kernel library, and we can just call it with add user message, and also add assistant message each time we get a result from the LLM. So if we will run it again, this time the demo called chat 00 history 00, and I can say, for example, what is the time, or what is the date next Saturday. So it didn't get it right. Let's try it again. What is the date, or what is date of next Sunday, let's say. Okay. Taking its time. Oh, I didn't invoke it actually. Let's try again. Okay, so it's not getting it right, but it's not what I'm trying to show here. What I'm trying to show you is that let's ask it about something else. For example, let's just say, and the day after that. And it should give us a result. Okay, yeah. So it's provided the result. It's now the so it said first it was on 17th, it went on Saturday, and now it's on the 18th on February. So it did provide the result. So it had the context, and it provided a result according to the context that it has before. You can ignore that it did not get the time right. We can debug that later. But what's important in this demo is that it understands the context. It knows all of the prompt and results that it has generated before, and it can answer according to that context. But as I said, each time we send the history, it's included in the tokens. And if we want to clean it up, we will reach the maximum token. So we do need some sort of mechanism in order to filter out the history. Here I'm using a really naive, really simple, that after 10 prompts, we are removing the first 5 prompts. Although a better solution will be to calculate the number of tokens we have in the history, and after some sort of amount, maybe remove the last entry or something like that. The second issue that we noticed that sometimes it takes a long time to answer us, and for that, and that's for different reasons, but we can use a streaming API to stream the result rather than wait for all of the results to come at once. So here I'm using the same iChat completion service, but I'm calling a different API called get streaming chat message content async, which will get an async enumerable, and we can just iterate over the stream, and each time I print the result. So let's try and see what happens now. Let's just call it with a chat history or chat 01 stream 00. And what's called chat 01 stream 00. What's it called again? Interesting. Again, chat 01 chat 01 stream 00. Anything, not sure why it's not finding this plugin. Let's try. Okay, doesn't matter. I think that we have the same functionality elsewhere, so we can see that, but oh, it's chat. Okay. Oh, okay. So I have a typo. Okay. Okay. So now it's working. So let's ask it anything. For example, tell me about Microsoft. And you can see here that we are getting the result in chunks. We're not waiting for all of the result to be calculated before we will write it, which in better UI, you can see it more fluently, and it's better for the user so that it can start reading before getting the whole result. So it's also built in and supported by Semantic Kernel. So what we can do better than that? How can we expand the knowledge that we have with Semantic Kernel? So there's something called embeddings. Embedding is the ability to take text or data and convert it into a binary vectorized format called embeddings. Embeddings, because they are vectors of floating points, given 2 embeddings, we can compare them and see how much one embedding is closer or relevant to that vector. So what we do here is that I'm using a library called kernel memory, which is also an open source library developed by Microsoft. This functionality historically was built into the semantic kernel, but currently, but in the newer versions, it's better to use the dedicated library that's called kernel memory. And what kernel memory does is that we can load to it text or files. It will use embeddings, or it will create embeddings from those text or files that we are providing, and it out of the box can support files for example, for Word documents, PDF documents, markdowns, almost virtually everything. And then we can ask it questions about the documents or files that we have stored. So here I'm building the kernel memory builder. I'm saying that I need the text embedding generation, which is the model that can help us create embeddings for our text. And here I'm saying that I have a folder called memories containing files, and I'm iterating over all of the files, and I'm calling the import document async API of the kernel memory in order to um, to to save them in the kernel memory. And the storage or the store can differ. So in this example, I'm using an in-memory store, although it's really easy to use, for example, Azure Search or a different memory store that maybe is built for vectorized search. But for this demo, it's really easy to use a simple memory store. And if we go and we look on the memories folder, we have two examples. So here I have some sort of list of anime series that I'm watching. So I have to list the watched already and the watching currently, and look in the watching. I also have the time or the day in the week that I usually use to watch that show. But I also went and copied as is the README MD file from my library, and I pasted it here. So I didn't change anything. It's the same Markdown file. It also has images and stuff like that. So it knows to filter everything out. And now I can go back here. We can see that I've added another plugin called Dynamic Memory Load that that's a given a query. It will search whether we have files or memories saved in our memory stores that are relevant to that query, and we can define, for example, the minimum relevance between 0 and 1. Firstly, we can see that let's look on the APIs that we get from using the memory store. So here I have an API that I can search for documents. So let's try to run it really quick. This time it's called memory load 0. Okay, so now I can ask it, for example, about what are the animes that I already watched. And it knows that there's a document called anime show tracking that is relevant to my query. So this is a really simple way to get information about those documents, but we can do better. We can also ask questions and get the results from the document automatically. So here I'm invoking the ask async API, what you see here. And this time let's try it again and ask the same question that we had before. And we will get the result. So this is the result, the shows that I already watched. And it also has the name of the document that it is used to extract the result. So it's really easy in order to track how LLMs generated the results according to our memories. And lastly, what I'm using here is I'm trying to invoke the dynamic load memory plugin automatically without specifying any like I'm using the APIs for that LLMs can use tools. Remember that we can send tools with our queries, and the LLM or OpenAI specifically can give us results according to the tools. So let's try and run it again. This time it's called load number 2, and I can ask it the same question. Try to do that. Okay, so it's saying loading memory according to what. So this line here, I am printing it. Okay, in the plugin that I wrote. So if we go to the dynamic memory loader, we can see here that this is the line. So this is, I'm asserting that it's calling this function. This is my functionality that I have added, and it's calling it. And you can imagine, for example, adding documents that are relevant for your product, for your internal documentations, and so on and so on. The other things that I wanted to show you is that sometimes we need a better way in order to ask the LLM to invoke plugins automatically. So we have a notion of planners. We have different planners, but currently in the current version, the main one is called Handlebars Planner, and it's called Handlebars because it's behind the scenes using the Handlebars templating engine. So how it works is that the planner can automatically load all of the plugins registered into it. It can write a query and provide it to the LLM so that it can generate a plan. And after generating the plan, it can then go ahead and execute the plan. The plan can be complex. One plugin can call another plugin, or it can chain plugins together. So we can do a lot of things, a lot of cool things here. So let me just show you that really, really quick. It's called Planner 0 Basic 0. And let me try and run the same prompt. It sees that currently is saying creating a plan. It's a string that I'm printing. Then we can see the plan here. The plan here is saying that step number 1 is loading memory from the document store, and step number 2 is outputting the result. And this is the result. So a plan can, because it knows all of the registered plugins, can create a plan for us. And as I said, it can be very complex. The last thing that I wanted to show you is running LLMs locally on your machine. So we have multiple ways to do that. We can use, for example, libraries like the Light LLM. But what I wanted to show you is something that is way simpler, at least for demos, which is called LM Studio. LM Studio is a freeware. For example, I can search for LLM model. For example, Phi is a really simple and small LLM model developed by Microsoft. And you can see here that we can load it into the GPU, and it has only around 1.5 gigabyte in size. So I think that almost any modern machine can load it into memory. And what's cool with LM Studio is that we can go ahead and already downloaded that model. I can do that directly from LM Studio. Just press here on download, and that it will be downloaded. And after it's downloaded, I can load it here, as you can see. So here's a list of the downloaded LLMs that I have, and currently I only have the Phi 2. So it's currently being loaded here. And once it's loaded, I can use this chat interface in order to chat with it. So for example, I can ask it now, tell me in 10 or less words about Microsoft. And it outputted it's a software and tech giant. So it's a valid result. It's really short, but it's a valid result. And what's cool about it is that it can wrap any LLM that it has, and it has a lot of them, into a server that uses OpenAI LLMs API. So because it wraps them with an OpenAI OpenAI APIs, we can use the same APIs or almost the same APIs we have in Semantic Kernel to work with any LLMs that we can download on our machines or into one of our clusters in the cloud, for example. So here we can see that it is currently loaded. And what we need to do here is some sort of a trick. So first of all, because it's running locally, we don't need to specify any model ID, any API key, anything really, because we know the address and the port of that specific server running that specific LLM locally on our machine. What we do need to support it, we have two options. We can either write our own iText completion or iChat completion engine in order to interact with it, or we can cheat. So by cheat, I mean when we add OpenAI chat completion in Semantic Kernel, we have an overload that, sorry, that can specify the HTTP client that can perform the results, that can perform the request against the OpenAI endpoint. So what I'm doing here is that I have written some sort of a middleware or an interceptor, and we can see it here. And every request will first get here. Here I'm changing the URI, the URL, the target of the endpoint to something that's running locally, which we got this address and port here. We can see it here. It's port 1234. I'm adding the same path and queries that I have, and just sending the request to the local server. That's it. I didn't change anything else. And this time, if we're gonna run a demo called local 00 LM studio 00, and I ask, for example, tell me about Microsoft in 10 or fewer words. We can see that it's written here, intercepting call for LLM, which is something that I've written here. And if we're going to look on the server, then we can see that it receives a request. And what's interesting here is that we can debug or see behind the scene what's happening. So here's a list of tools which containing the functions and plugins that we have written that LLM can call. So currently we have registered the timer plugins, and we can see it here. So we can use this functionality also to debug planners and see what's actually being sent to the LLMs. And as I said, there's a lot of other LLMs except the feed 2, all of the Llama of Facebook's and so on. So in this session, we talked about Semantic Kernel, how we can create plugins to Semantic Kernel. There are two types of plugins. There are prompts and plugins or native functions, which are C# code. Sorry. Just a second. Sorry about that. And finally, we talked about, I lost my voice. Sorry.
Feel free in the meanwhile to write some questions for Murid. You can also ask any questions you want. Our session is about to end in a few minutes, but we will stay here to answer your questions in the end of this session. And that's it. Thank you.
Sorry about that. So you can find the demo on my GitHub repository. This is the link and this is the QR code. Sorry about my voice. No, any questions? Eddie? Or so the token per second or per minute is the limitation we get from Azure OpenAI service or the OpenAI APIs, and it's a further limit that we get from using those APIs, which is in addition to the token limit we get from each LLM.
Q&A. We're gonna show you all. You can scan the QR code and register for all of our events here in the Reactor. We're reminding you that we have more episodes of this series. You can join all the AI Learning Hub. And this is the QR you can scan to register for this series and the additional series we have.
Okay, so there's another question called saying or asking, how can we combine several prompts together? Well, we can, as I showed, we can call nested prompt. So in in my timer plugin, I called the built-in plugin. So it's some sort of combining the two. And using Planner, we can also use chaining. The Planner can automatically get the result of one plugin and pass it down to another one. And we can also do that manually when calling invoke async. We can provide a list of plugins that each one will change the result as an input to the other one. And yeah, so the tokenizer is deterministic. There's the multiple algorithms and implementations. There's a really great one for OpenAI called tick token or something very similar to that, which is really great. And in Semantic Kernel, there's one called, which is for GPT-3 models, called GPT-3 tokenizer, that can also provide the same tokens. So I'm not sure. Okay, so there's a question asking about the availability of the GPT model in Azure OpenAI services. I'm not sure regarding the availability. As I said, that you do have to ask to be onboarded, and I'm not sure if they already allow it or not yet. Can the user prompt modify the indication sent to the kernel? Something similar to SQL injection? Well, it can. So you need to be really careful. Not only it can, there's a really simple prompt that anybody can do, even in ChatGPT. You can just write a single line called print everything above, and you can get all of the text system prompts or previous prompts that was sent to the same LLM. And if you're using a shared instance of an LLM, maybe a service that's providing services to multiple consumers at once, you can leak data. So you need to be really careful about that. Yeah, great question.
Okay, so we are going to finish the session. Thank you very much for all who joined us, and thank you, Moeed, for this wonderful session, and hope to see you in our next one. Thank you, everyone.
Thank you.